There we go. Let's start recording. Okay, so what we're going to do this time is there's a whole bunch of just sort of small catch-all problems. Maybe there's one or two of these on your exam. And what we want to do is, because these are all sort of small, short, quick and easy problems, we want to be able to do them. Okay. Now, the first one I'm going to try and tack is mean, median, and mode. Where am I getting this? Okay, that's not nothing. All right. So let's look at mean, median, and mode. So what mean is the same thing as the average. Okay. So what you want to do is you add the numbers. And divide by the how many numbers there were. So let's say I have something like this, find the mean. Of 2, 8, 9, 7, 3. Okay. Oops. So go ahead and add the numbers and then just divide by how many numbers there are. Okay. So we have the mean is equal to 2 plus 8 plus 9 plus 7 plus 3, all divided by 5. So that looks like 19 divided by 5. Let's see, is that 3.8? Let's see. 19 divided by 5 is 3.8. Okay. Now, usually this is the one that people are comfortable with. Okay, let's give everyone a second to copy.
Professor, that's not 19, I think.
Is it not 19? Let's see. This is 10, and then this is 10. So, oh, it's 29, huh? Thank you. You're right. So that would be, is that 3.8? Let's see.
5.8. 5.8.
5.8.
Mm.
Okay, thank you. Okay. So usually when we say mean is average, students are okay with this one. The ones that students get wrong more often are mode and median. So let's look at median. Okay. So median is what is the middle number? Okay. So the first difficulty comes the first difficulty comes is that a lot of times the numbers are not sorted. So we're not asking the middle number of some random list. We first have to sort the numbers. Let me give everyone a second to sort of breathe, copy, ask questions. So let's first sort these numbers. 2, 5, 6, 8, 9. And then we'll pick the middle number. Okay. So let me give you one. Let's do both. Let's find the median and average of 6, 1, 8, 9, 2, 4, 7. Well, yeah. Let's do that. Well, I should really say mean, because that's how they'll ask it to you on the test. So the mean would be equal to 6 plus 1 plus 8 plus 9 plus 2 plus 4 plus 7. So that's what? 7, 15, 24, 26, 37. Did everyone get 37?
Yes.
All right. So let's see what that is. So 37 divided by 7 is equal to, we'll just round it, 5.3. Okay. And then the when we want to find the median, we have to sort it 1, 2, 4, 6, 7, 8, 9. And then we want to find the middle. Okay. So then that's equal to like that. Okay. Now, I'm guessing that if they give you median, that's not the problem they're going to give you. I think definitely they're going to give you the numbers mixed up, but it's easier to find the median if they give you an odd number of elements. It's harder when they give you even. So my guess is that one, if they want to make this an easy problem, they'll just give it to you like this odd number of elements, and then, but you'll have to sort them. But my guess, the TEAS being the TEAS, where they like to have these subtle like trickery, is that they'll give you an even number of numbers. So let's say I give you something like this. Find the median of 23, 92, 46, 84. Okay. So if you write these numbers in order, Let me take a step back, give everyone a chance to catch up. So let's look at this, right? The middle is going to be in between these two numbers. That's where the middle is. Okay. So the way we find the middle in between those two numbers is we add the two numbers and then we divide by 2. So let's see. 46 plus 84 divided by 2 is we get 130 divided by 2 is equal to 65. So 65 isn't even on the list, but it's perfectly in the middle of those numbers. Okay. So let's erase this. So let me give you one. Okay. So let's write this in the proper order. 13, 14, 32, 43, 72, 98. Now there's 1, 2, 3, 4, 5, 6 of these. So we're going to be taking a look at the middle two. So this will be 32 plus 43 divided by 2. So that gives me 37.5. Okay. take a picture of this. Okay. Now the last one is mode. Okay. This is what number is repeated. What is repeated the most often. Okay. And this can be more than one number. Okay. So let's look at the different ways that they can give you this problem. So they can give you the problem like 1, 3, 5, 5, 8. And the mode would be 5 because that's the number that shows up most often. Now they could also do it like, well, let me give you a second to copy that. Now, the other thing they can do is they can give you something like this. So then the mode is equal to both 2 and 3. Okay, so you can have more than one. Okay, so when they give you one of these problems, this should be the problem that you should get correct and pretty quickly. Okay. Now the next one is 1, 1, 2, 2, 3, 3. So what's happening here is that all the numbers are repeated the same number of times. Okay, so over here, it could be either no mode. So if this is an option, pick no mode. Now, some books will say 1, 2, 3. Okay. So since you're a multiple choice test, if they put no mode on here, that's the one you pick. I think that's the more correct answer, even though some books teach this, some books don't teach it. Some books will just be lazy and do that. But given both options, pick this one. If there is only that as an option, then pick this one. Okay, so let's try drilling a little bit. Okay, so let's say I have 8, 2, 9, 8, 8, 2. Yeah, let's do that one. So I want you to find the find mean, median, and the mode. So the mean is equal to 8 plus 8 plus 8 plus 2 plus 2 plus 9. So 10, 20, 28, 37.
37.
Okay, thank you. Divided by 6. And then 37 divided by 6 is
0.16.
0.16. Oh,
6.16.
6.16. Thank you. Okay. Okay. Let's do the median. Let's sort it. Right? And we'll take the middle two numbers. And then we'll go 8 plus 8 divided by 2 is equal to 8. And then the mode is 8. That's the one that we have the most often. Okay, so it's not the one that is repeated, it's the one that's repeated the most often. So the mode is not 2 and 8, it's only 8 because 3 is repeated the most often. Okay, let's try one more.
Professor,
Yes,
Professor,
please.
the
Uh-huh.
8 and 2 is not.
2 is not.
2. Okay.
Right? Because there's 3 of these and only 2 of those.
Okay, got it.
Okay, so it's not the one that is repeated, it's the one that's repeated most often. So
Got it,
that's
got it.
where the common mistake is over here.
Thank you. Got it.
Okay, thank you for your question. Okay, now, so let's do the same thing. Find mean, median, mode. So the mean so let's see what that is.
170.
170. Thank you. 1, 2, 3, 4, 5. And then what does that turn into?
34.
34. Thank you. Okay. Now, if we look at median, it's right here. And then if we look at mode, it's 12. Okay, so this one is done. Okay, let me give everyone a second to copy, and then we'll do the next concept. Give me 1 second, check. Okay, so let's go and look at this. Give me 1 second. Give me 1 second. I just want to double check something that I tell you something right. Okay. All right, so let's get going. We want to be able to relate two variables. Let's clear the decks. Okay, so let's talk about relating two variables. Okay. Now, when you're doing experiments, you have your initial sort of variables that you are able to change. So for example, if you were doing an experiment on weight loss, Then some things you may measure is you might measure carbohydrates, or just measure your carbohydrates. And then what you want to do is measure carbohydrates, and then we want to see whether there is weight gain. Okay. This is what we can control. We can control how many carbs we eat, or how many carbs the people in our experiment are taking. A lot of carbs, a little bit of carbs, medium amount of carbs, right? So that is the thing that we can control. That's our control variable. Now, in terms of math, we call this the independent variable. So when we start our experiment, this is the thing that we're controlling. This right here is our dependent variable. It is what we measure at the end. Okay. So let's take a look. I have a little independent, dependent variable worksheet. Okay. And then I emailed these to you, but in case you can't grab it right away, I'm going to put it in the chat. And it's the one that says independent versus dependent variables. Okay. Now I'm going to pop it up, and we're going to look at this together. Let me share a screen. Okay. Now, don't yell out the answer. I want to give everyone a chance to think about it. Okay. So read the first one and tell me, and just write down on your paper. Don't yell it out. What is the independent variable and what is the dependent variable? So what is it that we are, what is the difference between the groups when we start our experiment? That's independent. And dependent is what did we measure at the end? Okay, so let's look at this one. So when we look at this, let me see. Here we go. Okay. So over here, cow is given growth hormone, is given a growth hormone, and one is not given growth hormone. So the independent variable is whether they're given a growth hormone or not. Hormone. And then the dependent variable would be the cow's weight after 2 years. Right? So this is how we set up our experiment, independent. This is what we measure at the end, dependent. Okay, so try doing number 2. So for this one, it's repellent versus non-repellent. And for this one is the number of bites. Right, that's what we measure at the end. So go ahead, try this one.
This number is mosquito?
Number of mosquito bites.
Oh, okay. Thank you.
Mhm. Okay. So this one is tap water versus salt water. And then the what you're measuring at the end is the mass. Try that one. So this is where they hit the brakes. And then over here, this is the distance traveled.
Question.
Go ahead, please.
That one, it wouldn't be the two different cars.
Yeah, I also got
Maybe.
different
I guess
cars.
so. I was thinking they're hitting the brakes at a different place, but I think you're correct. Okay. Two different cars. Okay. I'm gonna have to fix the solutions. I think in the solutions I put where, so let me write that down. Let me make a note for myself. So this is number 4. Okay, so let's do number 5. So number 5 is this one is a little bit weird because you're not really setting it up. I guess it's the wet, dry environment. Right. And then this one would be amount of time on each side. Okay. Okay, so you get the gist of this. Okay. So there's one problem. Okay. Now I need to find a worksheet for you to work on in terms of this next one. But let's talk about it, direct versus indirect correlation. So, let me grab my books. Okay, so direct variation is in the form y is equal to kx. Okay, now let's just do a very sort of basic variation. So let's say y is equal to your paycheck. Right? How much money you get. X is equal to the number of hours you work. And K is equal to $20 per hour. Okay. Now, it's easy for us to like think of this intuitively, that if I work 5 hours, then my paycheck is going to be $20 times $5 is equal to $100. Okay. Now, the idea of direct variation is when I work more hours, do I make more money? Right? Meaning that when my hours go up, right? When my hours go up, my paycheck goes up. Okay, so when my hours go up, my paycheck goes up. And that's what a direct variation is, right? The more I do this, the more this other thing happens. Now let's look at the inverse variation. Okay. Now that'll be something that looks like y is equal to x divided by k. Okay. So let's think of this in terms of weightlifting. The heavier the weight, the less repetitions I can pick up, right? So the heavier my barbell is, the fewer times I can pick it up. So over here, if we let y equals to the number of repetitions picking up my weight, and we let x is equal to the weight of the barbell, then we can see that as the weight goes up, my repetitions go down. So in terms of direct variation, the more you do something, the more the result happens. In terms of inverse variation, the more you do something, the fewer you can do it. So when we look at the graph of direct variation, it looks like this. The more I do something, right, the more X gets bigger, the bigger Y gets. Over here, technically it looks sort of like this, but they may give you something that just kind of looks kind of like a line like that. Okay, so in terms of a graph, right, when this X gets bigger, Y gets bigger, direct variation. When X gets bigger, Y gets smaller, that is inverse variation. Okay, so let's take a picture of this. Okay, so let's do some examples of direct or inverse variation. Okay. So let's say we do something like eating chips, gaining weight. Okay. Is that a direct variation or an inverse variation? When I do more of one thing, does the second thing happen more or happen less?
Correct.
It's direct, yeah. Right? When this goes up, so it's direct. Okay. So let's say running, and then gaining weight.
Running is lose weight.
Right. So the more I do this, does this go up or does this go down?
Down, it's inverse.
Yeah. Okay, so this is a
No, I think it go up because it's gateways go up.
no. You're losing weight though. What's the opposite? Right? You're not gaining weight. This is not happening when you're running.
Oh, okay, got it. Thank you.
Okay. All right. So that's inverse. Okay. So let's say trying to think of something. Let's think
Diet.
of which one?
Like a diet.
Okay, so we can say diet, and then we can say hungry. Okay. So the more dieting, the more I diet, the more hungry I am. So that's direct. Okay. And then let's say something like go to the beach. And then let's say skin cancer. Actually, let's do it something different. Let's go to the beach, and let's say
Get tan.
huh?
You
White
get
skin.
tan.
Get what? You get fat going to the beach?
You get
Get
tan.
a 10.
Oh, you get tan? I want something that does the opposite. What's the opposite of when you go to the beach?
This is inverse. Because you go to
Yeah.
beach, you get a black skin. You got
Yes,
dark.
yes. Yeah. So this is opposite, right? So this is inverse. Okay. So they may give you something where you're just comparing two situations, or they may give you a graph. Okay. Now, the other thing they may do is they may give you a table. So let's look at that. So let's say they give me something like the number of, okay, the amount, X is equal to the amount of chemicals in a petri dish. Okay, Y is equal to the number of bacteria colonies. Okay, so I want to know whether let's see, 2, 6, 3. Okay. Now I want to know is this a direct or inverse variation?
Direct.
Mhm.
The more bacteria grows.
Yeah, so absolutely. Okay. Now they may ask you is what is the constant of proportionality? What's it? Yeah. So one question they can ask you is this, and the other is what is the constant of proportionality? Now, does anyone remember seeing a 1 or 2 direct or inverse variation questions on their exam? I never asked
Yes.
anyone. You did? Was it a table?
Yeah.
Was it a graph? Was it a word problem? Do you remember?
It was a word problem. It was a word problem with the graph.
Oh, okay. So you just look whether it's going down or up.
Yes.
Okay. All right, good, good. I'm glad we're doing this then. Okay, so the way you find, so one way of thinking about this is that if I have a direct variation, I have y is equal to kx, where this is the constant of proportionality. Okay, so k should be equal to y divided by x, right? We can divide both sides by x and isolate that k. So I can go through this entire thing. It doesn't matter which pair I take. All of these are going to be equal to 3. That's my constant of proportionality. So if you look at this, you go like, I'm not sure whether that's a direct or inverse variation. Just divide the two numbers, and if you don't get the same number every time, it's not direct. Okay. Now the other way of looking at this. Okay, so let me give you a. So go ahead, copy that. Now give you another table with the same questions and the same setup. All right, so go ahead, copy that. give everyone a chance to copy what's on the left, and then we'll talk about this again. Now, because the X's are not in order like they were over here, it becomes less obvious as to whether this is a direct or inverse variation, mostly because we can't tell whether the numbers are getting bigger or smaller. Now, we could try what we did over here, right? We could say, check if direct variation, right? So we can check if it's a direct variation if we go 10 divided by 2, is that equal to 5 divided by 4? Is that equal to 1 divided by 20? And the answer to all those is no. These are all not equal. This is not a direct variation. Now, I want you to see over here that this constant of proportionality is the slope, right? It's the y over x. So if you're trying to remember which one goes on top, the y or the x, slope, y over x. And in pretty much everything that we're going to do, okay, we're going to go over correlation and covariance. Basically, everything is slope. So if you're not sure, like, does the y go on top? Does the x go on top? It's always the y on top. Okay, so if you have to make a fraction, it's always the y on top. It's always going to be slope. Okay, just like we did last week in terms of rate of change, slope, y over x, always, always. Okay, so it's always y over x in all of these questions. We're pretty consistent like that in math. Okay. Now let's look at the equation for indirect variation. So indirect variation is when we have y is equal to k over x. Now, if I want to isolate the k, I could multiply both sides by x. And I would get, these two would cancel. And then I would get k is equal to x times y. So we can check if it's an indirect variation by multiplying. By just going, does 2 times 10 equal to 5 times 4 equal to 20 times 1 equal to 40 times equal to 40 times 0.5? And the answer is yes. Indirect variation. And our k is going to be equal to, just multiply any two columns and you get it. Okay, now. Okay, so let me erase all this and then give you two tables, and you tell me whether they're direct or inverse and what the constant of proportionality is. Let's see. Oh, good. I did take a picture. I was worried I forgot. I didn't know if I did or not. Okay. So let's give you two tables. Okay, don't yell at the answer. Okay. Okay. So let's look at this. So the main question we want to ask ourselves is this direct or inverse? Okay. So direct is the slope, right? So it's is -8 over -2 equal to 12 over 3, and the answer is yes. That's what my k is. And if I were to multiply them, and the answer would be 16 is not equal to 36. So that would be not inverse, not inverse, right? This would be direct. Okay, now let's do the same thing over here. We'll ask, is this direct? When I figure out the slope, is this equal to and the answer is no. So this is not direct. So now we have indirect. All right, so this is my K. I should probably put a K here. So if it's indirect, then we're looking at multiplying. Is 6 times 6 equal to minus 18 times -2? And the answer is yes. K is equal to 36, and this is equal to 36. So this is yes. So it's indirect. Oh, Raul, should we take a 5-minute break? We can take a 5-minute break. Let's take a 5-minute break so everyone's brain can just like be registered. I could use a 5-minute break too. So let's come back in 5 minutes. Okay? So we'll come back. I'll set the timer. Okay, so let's get back to it. All right, so this is also in the packet of things I sent you. So it is the covariance example. So go ahead and take this. And it is the correlation worksheet. Okay. So if you can't find them, I just put them in the chat. So the covariance.
Professor, sorry.
Yes.
I have a
Yes.
question about the last one. It's equal, so is still indirect.
Yes. When you multiply them and they're equal, it's indirect.
Oh,
When
okay,
you
thank you.
divide them and they're equal, then they're direct.
Okay, thank you.
Okay. All right. So let's look at the covariance examples. I'm going to share screen. With you. Give me 1 second. Okay. Now, I'm sure when you took statistics, your teachers told you great pains to say correlation and covariance are not the same thing. In this test, treat correlation and covariance as the same thing. Correlation equal to covariance. Okay. Now, what you want to do is think of this as slope. So if we are moving up, it's positive. And if we are moving down, it's negative. I'm sorry, line going up is positive. Line going down is negative. Now, remember that this is collected data. You took a whole bunch of people's data, and then you put it on the on some graph. Okay. Now, the closer the data points line up to a straight line, the closer you are to 1. The further it is from a straight line, then it is then it becomes closer and closer to 0. So it could be a circle, it could be a weird shape. See how all of these on the bottom are not aligned? So that's why they're all 0. Okay. So go ahead, write that down. Okay. So let me write that. The closer the dots, the points are to a line, the closer the correlation covariance is 1 or -1. Okay. So just keep that in mind. So this should be a quick kill. If they give you a graph and you look at that and you go like, that looks like a line that's going up, close to 1. If it's a line going down, -1. If it's just a scatter shot of points, but it still has a general direction, up or down matters. But the more blurry it is, the more blurry of a line it is, the closer it gets to 0, but it's not 0 as long as it has an up or down direction. Okay. So let's take a picture of this.
Professor,
Mhm.
Professor, you said,
Yes.
no, what about the 0 was than 0?
Say that again.
Uh,
So this is 0 because it doesn't look like a line.
yes.
So this one looks like a little bit like a line, like a fuzzy line. And this
Mhm.
is an even fuzzier line. So these still have some value. These are not zero because they're kind of line-ish.
Mhm.
Okay. Does that make sense or no?
I confuse a little bit. You just say 0.8, 0.4. That's
Mhm.
the line is goes up. That's positive.
Yeah. So if it was a line, it would look like this,
Uh-huh.
right? So it's a fuzzy line.
Mm-hmm.
It goes in the direction of a line, but it's not exactly a line. Whereas over
Mhm.
here, see how this one is 1?
Uh-huh.
This was, see how that's exactly a line? So the more fuzzy it is, the smaller the number is.
Okay.
Once I get to over here, I don't know what direction to go. Do I go that way? Do I go this way? Do I go this way? There's no real direction. This one and this one still have a direction. That's why they still have some value to it. Just like
Okay.
over here, this one is a line, so it's exactly -1 because we're going
Mhm.
down. And then these are like a line, like they have a direction,
Mhm.
but they're a little bit fuzzy.
Okay. That means that zero is that zero is nothing. It's not a negative. It's not a positive.
Yeah, nothing. Yeah, because if I go, is this going up or is this going down? This going left or right? You're like, I don't know. It kind of looks like a circle,
Okay, got it.
right?
Thank you.
Got it? Right? I mean, this really, if you go, what shape is that? You go, circle. So it doesn't have to be a circle in order to be zero. It could just be weird shapes that are just not um, a line or a line-ish. Okay. Okay, now, so let's look at the correlation worksheet. Okay, let me bring this up. Okay, so let's look at this. Okay, so don't yell out the answer, but try doing number 1. Okay, so when we go left to right, the average traffic volume is going up. Okay? But as the average traffic volume goes up, the average speed goes
Up.
not up. See, follow
Down.
the dots, right? So as I go to the left, my Y values are getting smaller. Okay. So this is saying as traffic volume increases, vehicle speed decreases. So let's do this. Now let me ask you a question. Okay. Right? Is this a direct or inverse proportion?
Inverse proportion.
Yeah, because as this gets bigger, this goes down, right? So this is an inverse proportion. Okay. All right, so don't yell at the answer. Try number 2. Okay. So when you have a positive trend, the points tend to go up. Actually, let me make that smaller. Give me 1 second. Let me erase this. Okay. When you have a positive trend, your points go up, right? When you have a negative trend, your points tend to go down. So this right here would be considered a negative trend. Meaning that my points are going down. Okay. A constant trend means that my points are going horizontal. They're a horizontal line. So this one isn't any of those things. I don't see a line anywhere here. This is just a no trend. Okay, so let's go down a little bit more. Let's a little bit smaller.
Can I say the answer?
Sure, which one do you think it is?
I think it's A3.
Yeah, it's A. Okay, so that's here. All right. So let's sort of describe some of these. Okay. So this is a positive trend. This is also a direct variation. Let's move this over here. This one right here is a negative trend. This would also be a positive, I'm sorry, inverse variation. And our correlation covariance, it would be negative, let's say negative 0.5. I don't know what it is, but it'd be not 1, but negative something. Same thing over here. Oops. Our correlation covariance would be something like 0.5, but it'd be positive. Okay. This one would be a constant trend because it's moving horizontal. And this would have no correlation covariance. It'd either be 0 or undefined because it's kind of horizontal. And this would have, this would be no trend. And then the correlation covariance would probably be 0 or undefined. Depends on the book when it's horizontal or vertical. Okay. So let's think about what this what these different graphs are saying. This one is saying, right, this very top one, is that the more I study, the higher grade I got. This one here is saying the more I studied, the worse my grade got.
This is funny. More study, worse grade I got.
Mhm. This one here says, no matter how much I studied, I got the same grade. Right? My studying didn't matter. Over here, it says everyone studied about the same amount, anywhere between 3 and 7 hours. So everyone studied around the same amount, and whatever grade they got was pretty random. Okay, try doing this one right here.
Professor,
Mhm, mhm.
Professor, I think this is D.
You think it's D? Okay. So the more ticket writers, the more tickets. So I agree, that's D. Okay. Okay. So if, right, let's look at the other option. More ticket writers resulted in fewer tickets issued, right? Well, if that was true, right, the more ticket writers would give me, right, this is A. So the more ticket writers I have, the fewer number of tickets. That's what A would look like. What B would look like is we can't even write it here because we don't even know how many tickets are given them. Oh, actually, that's not true. This B would probably look like this. Actually, we don't know. Okay. And then over here, when there are 10 ticket writers, there will be 800 tickets. So what that means is when there are 10 ticket writers, there should be a dot here at 800. Okay. So let's get rid of this. Okay. Now this would be a direct variation, and my correlation covariance would be pretty close to +1 because it's going up, and that looks pretty close to a line. Okay. All right, so let's try this one. Now remember, correlation covariance mean the same thing, so they could change the word for correlation with covariance. Does anyone want a shot at this one?
Isn't it
Yes,
B?
Yeah, B. Yeah. Did everyone get B on this one?
yes, it's
It's
B.
yeah, it's B. Think of this almost like a positive slope. So yes. Okay, so go ahead, try 6. Okay. What do people think 6 is?
I think it's the water temperature increase as the heating time.
Yeah, yeah. So this is as this increases, this increases. So yeah, you're correct. Okay, just the picture. Okay, let's go to the next one. Let's try this.
Looks, Professor,
Mhm.
looks
Well, give
number
everyone a
seven.
give everyone a chance first.
No, I'm not the answer. I have
Oh,
not,
okay.
I have not read it yet.
Okay,
And,
what's your question?
I just say this picture. I think this is no trade. It's no.
I think you could still get a trend because you could still draw a line that kind of looks like that, right?
It means positive.
Yeah, so I think it's still a positive trend. Anyone want to take a guess?
It's A.
It's A, yeah, it's A. Okay, so let's try doing number 8. So for 8, they didn't give you a graph, they give you a table. So what you need to do is you need to graph the points on the table. Be very careful. Okay, look at the axis. So over here, number of students, that's going to be your X, and number of free throws, that's going to be your Y. Okay. Okay, so 7 and 3.
This is a positive.
Is it positive? Let's see. 2 and 1. 6 and 6. 7 and 4. 5 and 2. 3 and 4. 1 and 3. I think it's positive. So I think this is positive, but if you were to ask me the covariance of the correlation, it'd be pretty small, right? It'd be 0.3, 0.4, 0.2. It would definitely not be +1. Okay. Now, over here, you see the word quadratic. I don't think they'll give this to you on the test, but a quadratic is basically a parabola, like that or like this.
Professor,
Uh-huh.
I got B. I don't see no relationship at all.
I think it's kind of a line, right? It's kind of line-ish. So if you were to if I was to draw an ellipse that contains all of these guys. Oops. That's not good. Let me erase that. So if I was to draw like a circle or a shape that goes roughly around all these things, it roughly looks like, well, a potato, but it still has a direction, right? There's a long side, and the long side is going diagonally up. Does that sort of make sense? So it's not fuzzy, it's not round, it's not random. There's still a rough direction. So while I agree it's not a line, the correlation covariance would be very low, like 0.02, 0.03, something very small. But because it's oblong and it goes up, it's still a positive direction.
And is there an answer key to this one, Professor?
Yeah, at the very end, there should be an answer on the bottom of this thing. Okay. So let's look at number 8. We can look at the answer key. Let's look at number 8 on the bottom. All right, let's see if I can do this without giving everyone a seizure. So for 8, they went for B. Oh, okay. Maybe you're right. Maybe no relationship. So I take that back. I guess because it says linear and not correlation. So if it said positive correlation, there'd be a positive correlation. But it says positive linear. That probably means they want something that is much more of a line. So, okay, I think you're right.
That it will be
So
more, it will be much closer to the line. The points
to
will
a
be a lot
line,
more
yeah.
closer to the line.
Yeah, because it says linear. If it was a positive correlation, then it would be this. But okay, you're correct. Okay. Okay, let's try doing number 9 and number 11. But let's do 9 first. Anyone want to give this one a shot?
I went for C.
Yeah, I think it's C. I don't see any relationship at all. So I would do this one. Okay, let's do 11. What do people think?
D?
Well, let's see. As it gets hotter, does your air conditioning cost get cheaper?
No, no,
Because
no.
this is
D.
saying
D
I
as in
got
D.
A.
Okay. Yeah, D. Right.
I
So
got A.
as you A, okay, so
I got
A
it wrong. I
is
got it wrong.
okay. So if you got A, what this is saying, as the airplane travels faster, the amount of distance you traveled is less. Right? Because this is a inverse. Um, this is an inverse variation, meaning that the bigger X gets, the smaller Y gets. Right? So it can't be A because the faster the airplane goes, the distance should go up. I think it's D because the amount of distance you travel, as you travel, you have less gas. So I agree, it's D. Okay. I don't think we have to do 12, but let's do 10. So it's a negative correlation, meaning that when the first part goes up, the second part goes down.
A.
I think so, right? As it gets hotter, right? As the temperature goes up, the number of people wearing gloves goes down, right? So you could describe A as a negative correlation or an inverse correlation, right? Over here, the distance you live from school and the amount of time it takes to get to school, right? The further the distance, right, the more time it takes. So that is going to be a direct variation or a positive correlation. The number of visitors at amusement park, and then the lines get longer. So that one also is going to be positive correlation or direct variation. And then the student's height and GPA, that's probably going to be random. So that's going to be no correlation. Okay, so let's take a picture of this. I think we can skip 12. Okay. All right, so let's do 13.
Professor, I think is number B.
Well, which line fits the data the most? Like is in the middle of the data, right? For me, the reason why it wouldn't be B, because it looks like a line that is in the middle of our data would look like that. You see how this is? I think it'd be C.
It's C.
Yeah, right. So you're not looking for the one that follows the data, but you want the one that is in the middle of the data. That's what we consider best fit.
Confusing. I'm confused. Where is middle of the data?
So do you see all these points? So do you see how let's erase this up here. So in B, do you see how that line is above the data?
Yes.
It's above all the dots.
Oh, okay, got.
Okay.
Oh, got it.
You want to
Thank
pick the one that is in the middle of all the dots.
Oh, thank you, Professor. I got. Thank you.
You got it? Okay, thank you. So this is a good worksheet because it kind of tests you in a whole using vocabulary in a whole bunch of different ways.
Professor, so for a key takeaway for this one is best fit is usually middle of data, right?
It's always the middle of the data.
Okay, thank you.
Okay, so I think we don't have to do any more of these. I don't remember there being like y equal mx plus b on the exam. In fact, I don't think there's y equal mx plus b. So I don't think we have to do any of these. But for example, if you were to do best fit on these, like the best fit would be something like this, something like this, something like this. It's basically the shape that, and it's not always a line, but it's usually a line. So it's usually the shape that kind of centers all of the data. Maybe this one would be closer to like that. So those would all be considered best fit. Okay, all right, so let's clear this. And then, all right, so let's get rid of this, get rid of this. All right, now I have a bunch of just reading charts. So we don't have a lot of time, but let's just do a few of these. Okay. So let me share screen. Okay, so do problem 1. Oh, and then this is under frequency chart 2.
Number 1 is 6. Yes.
Huh? What's number 1?
7.
Okay, now that I
No, 7D,
specifically-
7D, 7D.
yeah, okay. So I specifically picked this one because they're going to trick you. Always look for that.
I didn't see that one.
Okay, so be really careful because a lot of times they'll set this up like, look, this is not that bad. You can count candy, and then somewhere on the side they'll say each one of these candies is equal to something. Okay. Okay, so the rest of these are pretty straightforward. Let me bring up another one. Okay, but I just wanted you to see, look for that little towel over there. Okay, so let me give you another one. Okay, so I'm gonna pop up the pie chart. Okay, and these I'll send to you for your homework. They're not that long. This is just like 1 or 2 problems. Okay. Okay. So try doing 1 through 5. Okay, don't yell out the answers. Just go ahead and just do them. Okay. So Wendy won the election. And Luke got the least amount. Okay, now in order to find Oliver, what we do is we go 100%
No, Professor,
minus.
Professor
no,
Page.
Professor,
Page
not
got-
Luke.
Oh, Paige. Oh, I'm sorry. Poor Paige. Thank you. Paige. Okay. So in order to find the what Oliver got, we do 100 minus everything else, right? 29 plus 21 plus 9 plus 12 plus 14. Did anyone do that? Already calculate that? Let's see, 21 plus 29 plus 9 plus 12 plus 14. So I got 85. Okay. So remember that the whole pie is 100%. So a very common problem is just to say, what's this? So you just subtract it from 100%. Did I calculate that right? 59, 61, 71.
Yes, Professor. I think I guessed it was 14, but didn't calculate.
Yeah, because
Yeah.
the Mike also Mike is 14%, and then is this called Oliver? Is that looks like the exactly same, huh?
I know you can't do that though. You're gonna
Yeah.
have to calculate it,
Okay,
okay?
yeah, yes.
Okay. All right. All right, so do Luke or Oliver. So Luke or Oliver is 12 plus 15 is equal to 27. And let's do the last one. Who had, all right, so who had about half the votes?
Wendy, Vanessa.
Wendy and Vanessa, yeah. And you can sort of see it because, well, over here, one is that 29 plus 21 is equal to 50. And then sometimes, you know, they won't give you the numbers and they'll go, who gave you half the vote? And you could sort of see that that cuts the circle in half. Okay. Wendy and. Okay, thanks everyone. My boss just called, so I gotta go. Thank you,
Professor, thank you
everyone.
so much. Professor,
Thank
thank
you,
you so
Professor.
much.
Thank you.
Thank you, Professor.